Welcome everyone. This is a flip about 12.2. It runs in the family. Today we're going to talk about monogenic, carrier, sex-linked, and pedigree. Okay, for the first part, I switch over to a book flip. Here we go. So, as you can see, here, and here is book. And then there is a capybara. Why? Capybaras are cool, right? Okay, I'll take my own book with me. Otherwise I can't see it. Yes. So the first thing is monogenic, right? Monogenic means it is monogenic, so one gene. And it's about disorders this time, because disorders make biology interesting. If everything goes normal, it's just homeostasis and it's normal and nobody cares about it. So always it is about how it doesn't function, because that's more important. Okay, monogenic disorders. The first one discussed here is phenylketonuria, or PKU. Well, it's a very rare disease, and it's a monogenic disease. So many diseases are inheritable from parents, but they are polygenic. So a lot more genes play a role. This one, PKU, is a monogenic. In this one, it's recessive inherited, which means it is inherited from parents, but on a recessive way. As you can see in figure 3 is down here. As you see that here, you see that Millie is healthy, Tom is healthy, Vince is healthy, but Lisa, she is ill because she got the two recessive alleles. Both parents are carriers of that recessive allele. So the word carrier means that you carry that gene with you, you carry the allele for that gene with you, the trait, but you do not express it in your own phenotype. So both parents are heterozygous, but they carry the recessive allele, which makes Lisa ill, which makes Lisa having PKU. There are more diseases and disorders than just this PKU, but we're just talking about this one, and we're giving an example of how it should look like. So carriers, that's an important one here. You are a carrier when you carry a certain allele, but do not show it in your own phenotype. And on the other hand, we're talking about this part of the book now. Here are dominant inherited disorders. Still monogenic, so still only caused by one gene. The Steinert disease is a very rare monogenic disorder, and the Steinert disease affects the kidneys, and it affects the liver and the eyes and the ears, but it is this pathogenic allele, so that sick making allele, is dominant. And therefore, if you look now in figure 4, you see that Dad has capital A, small a, and therefore he is ill. And Mom is healthy with two small a, so she is homozygous recessive, but Dad is heterozygous. If you look at the kids, then Isabel and Marcia and Aaron and Samuel, you see that Isabel and Marcia are both ill because they inherited the capital letter from their dad. Aaron and Samuel are lucky. They only have the small letters. You see, if a trait is dominant and it is also a disorder, then it's far more likely that it's passed on. So luckily, this is a very rare disease, because otherwise a lot of people would have it. Okay, so this is about monogenic and carrier. For now, I'd like to switch to the whiteboard scene to explain the other topics. And the other topics, they are about pedigrees and about sex-linked. So, first about sex-linked. Do you remember we have a normal Punnett square with dominant and recessive, and we just cross it on, and you get things like this, right? It's all, as we say in Dutch, gesneden koek now, I hope. But there was also last lesson we talked about co-dominant. Remember that? So we have blood group A, for example, which has immunity factor A and maybe a small I. So this is blood factor A. where you have A, B, which are co-dominant to each other. Yeah. Okay, so let's make it more interesting. There is also another type of crossing, and this crossing is sex-linked crossing. Sex-linked brings an interesting opportunity for genetic codes, because sex-linked means this is on the 23rd pair, and the 23rd pair is in boys is the XY. In girls, this is the XX. And you know that the Y is an incomplete X. So there are almost no traits, no genes on the Y chromosome. And that makes it important in this case, because I'm going to explain you color blindness. And color blindness is a sex-linked disease. Color linked, no, color blindness. Right. And I'll show it how you write that down. So if you have color blindness, it's a recessive sex-linked disease or disorder. So if your X chromosome shows a small a, you need another small a to make it appear. So for girls, these girls are colorblind. For boys, on the other hand, you only need one small a, because the Y chromosome almost has no genes, so no traits. So it's monogenic and only one allele is needed. So boys are colorblind when they have only one small a. Of course, boys can be color seeing, like most of us are, right? This is color seeing boy. And girls, they can have this genotype where they're color seeing, and girls, they can be carrier for this trait. So they show one healthy allele right here, but they also have one ill allele. So these girls are carrier for color blindness, but themselves they are color seeing. Okay, now let me draw a Punnett square and a sample for you. So a heterozygous girl and a color-seeing boy expect a kid. What chance do they have on a colorblind boy? Is it A, a half, so 50%, a quarter, B, or 25%, or is it C, 1/8, or 12.5%, or D, 1/16, 6.25%? Pause the video for a while and until you have the answer, and then have a look at the answer. See you back in a second or so. Okay, welcome back. I'm going to explain it now. Actually, this is two questions and not one. And because they're expecting a kid, and a kid doesn't determine if it is a boy or a girl. And therefore, there are two questions. Color blindness is stated as she is heterozygous and he is color seeing. So if you're color seeing, you have to have a capital letter. So his genotype has to be X capital A, Y minus. Hers, she is heterozygous, so she has X capital A, X small a. Okay, let's write down the alleles. And in this case, you have to be careful because this is one allele, this is an allele, this is one allele, and this is one allele. Okay, so X capital A, X small a, X capital A, Y minus. X capital A, X capital A, X capital A, Y minus. X capital A, X small a, Y, oops, not Y minus already, that one is later. X small a, Y minus. So the ill kit will be this one. All right. So so there is a 25% chance of having a kid which is ill. And the other thing is, there's also, is it a boy or a girl? So there's 50% chance of having a girl and 50% chance of having a boy. Now a new question. Is the answer here 1/3 or 1/3 times a half, so 1/8? Or another way, is it answer B or answer C? I leave you to this to think about it for a while and come back in a few seconds. The correct answer here is B, 1/4. Because this is sex-linked, you already divide on X and Y in the first crossing, so you don't have to mention the second crossing. If this was on a normal, if it was normal monogenic trait, which inherited, so let's say eye color or so, what will be the chance of having a boy with blue eyes or straight hair? And then you should count as well for the X chromosome and the Y chromosome as the sex-linked ones, as the one that linked to sex, so determine the sex. But in this case, it is already on the sex chromosomes, so the chances were 50% chance on a girl and 50% on a boy, and out of those two possibilities, there was one boy healthy and one boy ill. So the chance here is 1/4 or 25%. Okay, let's move on to our last topic for today. The last topic here is pedigrees, and pedigrees in Dutch is stamboom. Okay, in a pedigree, you should know a few simple rules. A square is always a boy, and a circle is a girl. When they're linked together, they are married, they had sex together. Okay, this line described that out of that sex came kids. So you could say that this is a family of a few generations, and you could say that this is the P generation or the parentis generation, and then this is the F1 generation, and these here are groups of F2. So this is the F2 generation. And the second generation offspring, the first generation offspring, and the parentis. Okay. So you could say these are grandfathers and these are grandmothers. These are parents and these are children. Okay, so there's also something to know. If something is colored, then it has a certain meaning. And in this case, colored means colorblind. So a pedigree is a very handy way to sort things out genetically. So you can easily write the genotype underneath. So let's find that out, how it works again. So as we just discussed, color blindness is a sex-linked trait. Therefore, I know for sure that this boy's genotype is X small a y nothing. I know also for sure that hers, of the girls are in the same family, hers are X capital, X, I don't know. See, X capital, X, I don't know. The capital I'm sure, because otherwise they would have two small a's and therefore they would be ill. So I also know that grandfather here is small a y nothing, and grandmother here is capital A X, I don't know. For this one, we know it's also X small a X, excuse me, not X, but Y nothing. And this one is, of course, X, capital A X, I don't know. We see that they got a kid, the uncle from this boy, who is ill. So, we also know that they have kids which are healthy. For example, this daughter, which is the mother of this boy. So then we also know that this mother has to be a carrier for the small one. Why? Well, that's because father is healthy, but has to pass on his Y to his son, because otherwise it wouldn't be a boy. So we know that this trait carries from the mother side. So then we also know that grandmother should be carrier for this one, because she has a son which is colorblind. We don't know if the small a here comes from mom or from dad, because girls get two X's. Okay, this sounds really confusing, so maybe you have to rewrite it a bit. But pedigrees make it very visible for you to find out. In the book, there are some really good exercises to train you on pedigrees. And later on in the lesson, I'll tell you about an assignment in which you can make a pedigree of your own family. Okay, important things to remember is monogenic is only one gene which carries it, which carries a disease. A carrier means that in the phenotype it doesn't show a disorder, but it carries it with it in the genotype. Sex-linked means that it is on the X or the Y chromosome, almost always the X chromosome. And a pedigree is a handy tool in which you can show how a certain genotypic or phenotypic uh, genetic disorder travels along in the family. All right. Thank you very much for your attention. See you next week. Bye bye.